So with that, I want to start a new project, and I'm doing it intentionally so that you are not confused about what you need, how to start a project, and all these things. Okay. So suppose you have PyCharm, you have installed it, and you want to start a project. This is how you go. So click on new project. We are using pure Python. Now it may ask you if you want to create a Git repository. What this simply does for you is that that Git init step that I showed us the last time, you don't need to do that anymore. So this guy creates a local Git repository for you. And this is one of the reasons why I keep emphasizing that Git and GitHub are two different things. Git is on your laptop, GitHub is on the internet, is on the cloud. Okay. So when you do create Git repository, you have done Git init, and a Git repository is created for you locally. If you click here, what it does is it creates a Python, like it writes some demo Python code. I don't know if you remember the last class. When I started the project, it looked empty. That's because I did not check this part. Okay, so this is not required. Actually, it makes sense for you to have an empty script, but of course, let me just do it so that you can see what's going on. Then I think I want to give a name to my project. So let's just call this Conditionals, because that's one of the major things I hope to do today. Okay, and then it then talks about an interpreter type. So I didn't want to get into all these complexities, but Python is what we call an interpreted language. And one of the major ideas there is that it interprets from top to bottom. And then you selecting an interpreter is just to determine is determining which programming, if I should, let's say programming component is going to convert your code into bytecode that the computer can understand. That's what it basically means. Okay, so it's generally recommended to use this project venv, right? That's what I'm going to use. I already have Python installed. I think 3.15 is the latest, but so I want to say this up front. I think I've mentioned something like it before. I said that in tech, a lot of improvements happen very quickly, and so you keep seeing versions upgrade. But it's also a good thing to not be very quick in upgrading, because sometimes, if for instance you are using the latest version of Python, not everybody has adjusted their projects to that new version of Python, and so it may hinder your ability to use some things that are already available. That's one. The other thing is it may also be unstable, like something is still in development and you're using it, so they used to call it beta version. So for that reason, it is recommended that when you are upgrading, you should check, right? Is it stable now? Is it now widely adopted and things like that? So just know that you want to be a little bit careful as you upgrade, right? But I don't think 3.13 is bad. That's like 2 steps behind 3.15, so we are good. Anyways, for this, I think I already have 3.11, so I would go ahead and use it. Okay, so let us go. It is creating the project for me. So yes, sorry for everyone who already has great understanding of this. I'm largely doing this because of Michael. So again, now that I'm here, there's this part where I said after you do git init, that you have to do git add. So in Git, there are like 3 different areas that your code can be. But these are just basically folder arrangements in your laptop that helps you keep track of your code. Okay, so I wish I could show you a drawing to signify it for you. But anyways, just listen attentively, please. So you have this local repository. There is what is called a staging area, and of course there is your folder where this code is domiciled. So this is actually this conditionals. Now I can go to my folder or finder in Apple. I can go there and look for this particular code, this particular thing on my laptop, right? It's actually a file, main.py. Okay, so these 3 components, you should actually understand them, that they are not the same thing. Your staging area, the local repository, and then the folder itself where your code is. So I don't want to click this add so that you understand the step, but adding it actually means I'm adding it to Git. So let me do it manually to show you what really happens. So the first step now is that this thing is already in my laptop, as you can see. Okay, so this main.py is already in my laptop, and that's one of the reasons why it is showing red. My ID called PyCharm tries to talk to me without me without basically writing, but with colors. So that's the idea. So since I already have this step, I've already done Git init because I clicked create a Git repository. So what this does, it initializes a Git repository for you locally. It creates the repository, but actually it is empty. There's nothing there. Okay, so after this step, if you have a file, what you want to do is to do something like git add. Many times people say dot, but the idea what dot does is that everything inside this conditionals folder, it adds it to that place where I call the staging area, right? It adds it to the staging area. So that's actually the idea. I hope you are listening to me. Is everybody getting what I'm trying to explain?
Yes, sir.
Yeah, so if you listen to me very well, you will understand how Git works, and many things wouldn't trouble you anymore. So this Git add space dot means, everything inside this conditionals folder, please put it in the staging area for me. But it's very possible that I don't want to push everything. And also, just to show you the principle, I want to do something like this: git add main.py, and it is going to check this main.py is expected to be inside this conditionals folder. And for our case, yes, it's actually here. So I'm going to add it to the staging area. Okay, git add main.py. So it has done just that for me. Okay. You can see now that the color has changed to green. All right. So then the next thing is, this is in my staging area, but I want to move it to my local repository. Now note, local repository is absolutely different from your remote repository, which is on GitHub. So everything I'm doing now is away from GitHub, right? This is actually Git on my laptop, and it's just keeping track of changes for me. One of the things I could do, of course, I don't want to get into those details, but yes, Git does a lot more than you can notice immediately, and I'm only just not showing you so that you don't get confused. Yes, for instance, everything that I'm doing right now is timed. It can tell me the exact time, it can tell me who pushed it, and all those kind of things. But just know that it's doing all of those under the hood. That's why we actually create Git repositories. So the next thing I want to do is to put it in the local repository, and we call that a commit. That's what we call that. Okay. So to commit, this is the command line. Again, you can do these things from here. I will show you how to do that later on. So let's do git commit. We then say -m. That -m is you want to commit with a message. So I want the message I want to write here will be created the file. So this is what I want to do. So now this commit, all it does is it takes up everything in the staging area and moves it to the local repository. So let's say, for instance, I've done git add main.py, and that's the only thing on the staging area. But I've not added, maybe, of course, it's not advised to push it, but let me just use it to make the example. Let's say there was external libraries here, right? And I wanted to actually push it, right? If it is not in the staging area, it will not be committed. It is only the things in the staging area that will get committed. Okay, so I am pushing these things, or properly speaking, I am committing these things to the local repository now, from staging area to local repository, before you then talk about moving it to the GitHub, which is what we call pushing. You push it to GitHub. So let me do this now. And okay, so actually there's something that's going on here. It is pushing on this file called .idea. .idea, I don't know if you have heard this before, but things that begin with a dot in your laptop are normally hidden. And that's one of the reasons why you may not be seeing this .idea here, but it does exist. Okay, so it is actually a hidden file. If I had known, I wouldn't have, put it in. But yes, I think it's already committed. That's the reason. So I have pushed all these things inside .idea folder with my main.py. They are now inside the local repository. I also want you to note that main.py has changed from green to white. That means they are in my local repository now. Okay, that's what it means. Now the next step will be for me to push to GitHub. Okay. But before I continue with that, I want to say something to you called or introduce an idea called branches. So let me go to GitHub. All right, let me go to GitHub. So when you create a GitHub repository, of course, I've mentioned a number of times that it's different from your local repository. It is just like an empty folder, as it were. But GitHub and Git is meant to track changes to code. Okay, so one of the things it does is that you are expected to be able to create what we call branches. A branch is a place where a version of the code is actually stored. So let's say, for instance, I want a big portion of, let's say I'm using an app, okay, and one person is working on the front end, another person is working on the back end, and they are meant to be in the same place. I can later on push these two branches together. I can literally merge them together from two branches, okay, but they are still in the same repository. This is a very simplistic way of me trying to explain the idea of branches to you, but yeah, that's actually it. Okay, so let's call this conditional. Okay, so yes, it's available. I'm leaving it as public, and it is trying to create the repository for me. Yes, it has created it. So you see these instructions here, and this instruction is a command telling me that please create a readme.md for me. Okay, this git init is the step I said has already been done because I did create a git repository. Git add readme will add the readme that I have created to my staging area, but I don't have a readme, so I'm only interpreting it for you so that you understand what is going on. For my case, I have main.py, right? So, and then I committed it. I think you have seen me do this one. The only difference is the message, okay? Then eventually I want to do this. I want to create a branch and call it main. This PyCharm has a way of telling me what is going on. As you can see here, there's this thing at the bottom, sorry, at the top, master. It tells me all the branches that is available. The master branch is like the default branch that it creates when you initially start a repository, okay? Later on, it was changed to main. So many people, GitHub themselves, advise that you create a branch called main and not push to the master branch. All right, so that is why I'm taking up that command now. What this command is going to do is that it's create a new branch and call it main. So just keep your eye on this top left part here that has master and see what happens when I create this branch called main. Okay, you can see that it has changed. This means I am on the main branch, and anything I push, it will not be going straight to the main branch. Okay, does the master branch still exist? Yes. Now, one of the things I want to tell you is that these branches store different versions of your code. Let's say, for instance, I commit things to my main branch, and I go back to master branch. When I go back to master branch, the code that I left on master branch is what is going to be there. It will not, shift all the code from main to master. It's as if, not as if, you literally have different versions of your code, and that is the major use of Git. I hope that is clear. So I can have different versions of code in main, master, different things, develop, staging, any branch. You can literally create a branch with absolutely any name. Of course, you wouldn't want to use master because master already exists. And then you want to make it intuitive. This main branch, generally, I think many people leave it as their production branch. This is the main branch. That's what it means, right? So let's say I am doing something like testing. I can literally create a test branch and say, okay, this branch is only testing code that is there. So that's the idea behind branching, okay? The next instruction that it tells you is that please link up this GitHub repository with the local one. That's what this command actually means. So I go git remote. Remote is something that's not with me locally, it is on the remote. So I want to add it to, origin is like, where's the origin of it? And it's on this URL which I'm connecting, which is the URL for this particular GitHub repo I have created, okay? So that's basically what it is, git remote add. I'm adding this remote origin to it. So I'm going to press enter now. And if you don't see anything, just know that they are now connected. My local repository and this particular repository I created are now connected together. Now, at this point, I can push code in my local repository to my remote repository, which is basically GitHub. I also want you to know that GitHub is not the only VCS that we have. By VCS, I mean version control system. Okay, so we also have, I think, to be honest, GitHub is the most popular, mostly because it's free, I believe, and it is owned by Windows at the moment. They bought it from the original guys. So we have what we call GitLab. Yes, there's GitLab, but I think you need to pay to have some kind of features. Of course, if you want to use GitHub for as a company and you need some of those other features, you have to pay, but GitHub has a lot. For instance, they have Copilot, which is like AI writing code for you, and you can run code on your online without getting the code locally. You can literally run GitHub repos online. So, but yes, I think that will be a lot. Yes, let me take your question, please. I think I've said I've said more than necessary. Please ask a question.
Yes, sir. Thank you so much, sir. So now I enjoy seeing this, right? It's cool where we see that we can use codes to on the terminal to do all those commands. But but I did not go through that route. I just did the I did not have to create a repository on my GitHub. I just made my GitHub on my IDE and then shared my current work with my current work on my Git, and it created a repository automatically. It moved the repo to my GitHub. I don't know if you understand what I'm trying to say, sir.
Yes, I think that's a GUI that PyCharm allows. What you are saying is that you didn't go to github.com on your browser to create a repository. Is that what you are saying?
Yes, I did it. I just all I did was to go to Git, go under Git, no on your menu up. I on your menu up. No, still up. Yes, yes, under Git. On GitHub, I just clicked on the yes to tell you share project on GitHub, and that was how I moved my project to GitHub directly.
Yes. So if you click on, anyways, I've already added it manually with command line.
Yeah,
If you click on this, you have to previously have connected your GitHub account with your IDE.
yeah, yeah.
Yes. So
Yeah,
if
so that's
you,
what I did actually.
all right.
But does that work also? Does that make it? Is it also that makes it seamless also like this, right?
Yes, it's very seamless. One of the reasons why many developers like me will recommend this is that there are many possibilities. Maybe you are working with a laptop that's not your own. You are working on an ID you have not used before, and that ID may not be PyCharm, right? It may not have this feature.
Oh,
Okay.
oh,
Generally speaking, it's just good to know the original because what they're actually doing is to run this code under the hood. That's what they are doing, right? So, but honestly speaking, I recommend that if you already know the command line, then you can continue to use the GUI, like that's the graphical user interfaces for simple things. And when it gets to something complex, you come back to command line. For now, I don't think you will encounter any complex thing, and the GUI is absolutely awesome. For instance, I've not pushed to the remote repository yet, but let me show you something. For instance, so this thing is white now because everything is on my local repository. If I do like this, you can see it's now blue. It means so there's a change that you have not added to the staging area or looker tool. So that's what it's telling me. Another thing is look at here. I can literally just come here and say, do you know what? Please commit all these things. See all those commands I was writing. I can just from here I can commit it. In fact, there's now something where those commit messages I used to write, AI can write it for me, can check what did he do. So if I click here and I have the right credit, okay, I've not installed the plugin. I normally use the Java ID, but if I had installed this plugin, if I click here, it will come up with a commit message for me. That -m commit message, it will write it for me here, and all I will just have to do will be to click on commit and push. It will commit it to the local repository and then push it to the remote repository for me. So this is the GUI. But like I said, I always like to show the command line first so that you really understand what is going on. So yeah, that's actually it. This is the Git CLI. CLI means command line interface. GUI means graphical user interface. Okay, so finally we are ready to push. Michael, I hope you have been following so far. You are one of the major reasons we are doing this. So eventually, I'm reloading this page and there's nothing here, but if I push, you should be able to see everything that we have. So the way to push is to say git push origin. You want to put add name of the branch that you are on, that you are pushing to. So git push origin main, this should work. Let's see. Of course, if it doesn't work, you just normally find out what was the problem. Maybe authentication issues. It will be like, do you have permission to push to this repository? Especially when you are working with somebody. But yes, I think this worked. So it counted the objects, pushed 100% of the code to the repository, blah blah blah. So if I reload here, you will now see the code that was on my laptop now remote. And if I send this link to you, you will see the code I just pushed. So yeah, that's how to push to a Git repository. So this is the code on my laptop. You can see it here. I think we have spent a lot of time on this. I want to introduce us to conditionals and we'll be good to go. So Michael, do you have any questions?
I prefer. I have questions, but I want to go through it myself. So I would observe the distinctive on how to do it. So I can do it on my own.
Okay.
Yes.
I wish I could show you my face as I'm smiling. You are a very good university student. Anyways, let's go on. So if you can still see my screen, I think I want to introduce you to conditionals and we can go ahead. I believe some of us have read through a large part of this, right? So we introduce you to conditionals, and then we want to talk to you about what a simple decision is. So a decision just says, oh, if this, then that, right? If not this, do this other one. If not this, do this other one. So we want to check out how this works in code, in programming. Of course, we're using Python, all right? So this is the first example that we have here, and I could just use it, okay? Also, I want to, I don't think this is a good place to say this thing, but maybe later on I will introduce us to the idea of a function, how to create a function, and this is basically what you are seeing here. They created a function called print hi. Okay, so we'll get to this later on. For now, let me just maybe comment out everything you can see here, right, and then we can do our own thing. I think it's also okay for me to maybe use the function to do what I want to do. All right, so if x is greater than 0, print that x is positive, isn't it? That's what they're trying to say. I want to also tell you something about indentation. What is indentation? I think if you were attentive in all those English problems they were showing you in secondary school, they will tell you that if you are writing a formal letter, you should indent to the right. After your first paragraph, you should indent to the right. I believe all of us understand that language. So that's the same thing in Python. Many languages use what we call brackets. I don't know, is it appropriate? Should I show you people Java code? Right, but yes, like some languages like Java use brackets to make that, to know, okay, this is where this thing stops, go to the other part. Python, on the other hand, uses indentation to check. Please listen attentively. This may confuse if you are seeing it for the first time. Okay, so in previous things that we have been doing, we have just been reading code line by line. Like your last assignment, you collected input from a user, and after collecting the input, you just printed it out straight. Okay, but let's say we want to do something like this. Let's take an input like we normally do. Input from a user, and then we are like, give me a number. Give me I think let me assign it to a variable. That will actually be better. All right, num write a number. Okay, and then let's say the person gives a number. We want to change it to an integer. So we integerize num. Okay, and after we integerize num, this is where my if statement now comes in. I want to say that if the number, let's call it num, like we said, is bigger than 20, I will put a colon, right? And then I'll press enter. So this ID automatically does it for me because the ID already knows that if statements should be proceeded with, after it should put an indentation. So it does the indentation for me. Let's say we're using VS Code or any other ID, and for some reason it doesn't get to that point. You should press your tab key, or you give 2 spaces like spacebar 1, 2. Okay. I actually prefer the tab key, and it's becoming a standard in Python, even if you can do otherwise. Okay, so the tab key is 4 spaces, not 2. But if you do the 2 spaces, it will still work. So that's what indentation is. That is how to tell Python that, everything that is indented to the right is actually under the if statement, so it's not on its own. So technically, anything that is indented inside this if statement now will only work if this part is true. Okay, I'm putting inside brackets, but that's not necessary. So if this condition here is correct, is true, then it will then do whatsoever I put in the indented part. Okay, so let's say print. Let's tell it print. This number is big. So this is what is going to happen. Okay, so I will press play here. So let me print. Oh, that's also true. What if, okay, let me just make it true for now. Let's put 21. So this number is big. But you see, if this number is not big, what are we going to do? Right, so I'll get back to that. But before then, I just want to show you that if there was any other block of code after the if statement, that it will still run. Let's say, for instance, I do something like this, and I say print end program. Right. So let me run it again. Write a number, and then let's say I write 12. That means this thing is not fulfilled. It doesn't do anything here, and it just ends the program. I hope you can see it. Right, the program has ended. So that's actually what is going on. That is how. So don't think that it's only the if statement that will start running. Once you leave the if block, that means you are done. It will come back to reading everything line by line again. All right, so this is basically what the if statement is about. This is what the if statement is about. Now, I wish to show you how to come up with conditionals, because conditionals are basically how there are things that can result to having true or false. Okay, so this is not the only way to get a true or false statement. There's less than, there's equal to, there are many other ways. So maybe we'll get to that later on. But my priority for this class is to teach you how to write if statements and then deal with them very properly. So let me try to follow the notes just the way it is. Okay, so this is an if statement, and I believe you now understand it. And also in the other class, I told you guys about what a boolean is. Right, a boolean is just true or false. And so these are the things that make us result in having a boolean. Okay, so next is you want to now ask, what are boolean expressions? Okay, boolean expressions. You can obviously see the greater than or less than, which is what I've already used. Let me just copy all of them, and then we'll use them in actual examples. Again, this is kind of mathematical, and then if you are already good with math, this shouldn't give you a problem at all. I'm using docstring that I introduced us to the other time. So this is a docstring which allows you print many, basically is multiple comments. Multiple comments. Let me stop there for now. Okay. If is greater than, this works, right? Yeah, you can already see greater than here. So here, then let me start from the top. Let's do equal to. So this equal to, I'm calling it equal to like literally, so that it will not leave your mind. It is different from this other one, which is just simple equal to. So you know that in mathematics, you can say that, if x is equal to 0, in programming, that's not how you do it, because we have already used equal to mean assignment, to give a variable a value. I've already used it, so we cannot use the same symbol to be comparison. So in order to compare, what we do is we write equal to 2 times. That's what we do. Okay, so that's how we do it. So this now means if the number is equal to 20, this is a number. This number is big, right? If it is not, it will just simply tap out. So let's go here. Let's do a number. Let's say 20. Okay, the number is big. Fine. If I run the program again, and then the number is maybe 19, end program. So that means that this block of code did not run. It did not work. That's what it means. Okay. So we could actually look at it and be like, what if we want to try less than? Actually, what my intention is to do all of them for you. So let's do less than. Okay. So less than just simply says if it is smaller than 20, that means this number is smaller. Right, if it is smaller than 20. So let's say 12. So the number is small, isn't it? So there's this other part that is less than or equal to. Now I want to tell you also that let me show you. Let me run this program again. Let me do 20 so that you see what will happen. 20 on the dot. You see, 20 is not less than 20, so it didn't work. Okay. So, but by the time I add this equal to here, you see that it's actually going to work. Let me put 20 now. Are you seeing it? So the idea of equal to and less than together is, if it is less than or it's like putting two conditions together. That is also the same idea behind greater than or equal to. I think you have seen greater than. Then there's this last one I need to show you. This is not equal to. We use exclamation mark to say it. Not equal to. So if num is not equal to 20, what are we going to say? This number is not 20. Let's do it. This number is not 20. So yes, let's try. Let's write a number and then let's say 15. This number is not 20, right? Of course, it's still going to print end program, right? Okay, but let me run the program again and let it be 20, right? Are you seeing it didn't work? Right? Because this number is actually not 20. Now, this thing I just did is very simplistic, and you may think it's very simple until you start fighting, trying to understand certain, writing some kind of code, and it's as if it has many Boolean operations, and you have to be thinking. But one thing I want to mention for you is that there are other Python keywords that may lead to Booleans, but these are the conditional expressions that you have to remember immediately. For now, maybe as time goes on, if we encounter all the other ones, I would let you know. It's also possible to store the value of a Boolean, like this num equal to 20 now. I can store it as a value, as a variable. Another thing also is that this value, you should know that it actually evaluates to true or false. Like let me try it. Let me call Control X. Okay, let's call it truth value is equal to key. So if truth value, but I think I want to do something first. I want to be able to print truth value first. Okay, so let's write a number. Let's make the number not equal to 20. So let's do 15. Okay, so it printed the truth value. The truth value is true. Indeed, 15 is not equal to 20. So it then say if true, print this number. And of course, our truth value is true because 15 is not equal to 20, right? And then after doing everything, it ends the program, right? So this is just to let you know that you can actually save the truth value of an expression inside a variable. And I hope this makes sense to you. So don't forget these. They're actually mathematical operations, but this is the computer's way of understanding these mathematical operations. Okay, all right. So they mostly deal with numbers, right? I don't think you can use many of these with strings, but you can use equal to with strings. You can use equal to with string. Like maybe you want to check if two strings are equal. It's not wrong for you to actually use equal to say, oh, is m equal to this other value, and it will actually work. I also think that it's okay for you to use it with not equal to. But for greater than or less than, I don't think there's a particular way to check if a string is greater than another string, except you are talking about the length of the string. Okay, so this is for this aspect, and very soon, so I want to introduce you to something else, and we'll stop for now. let's try to do everything. I'll be very fast, please. I want to show you everything about if and else statements, and we'll continue with our conditional stuff in the next class. So now that you have done if, truth value, and all these things, I also want you to know that, let me take it out. I'll keep using my example. Let me also use something that your mind can easily relate to it. Let's use greater than or equal to, right? Print truth value and all that. Now, if this thing is true, we said print a number. We are also going to deal with it to say that, well, what if it's not true? What do you want us to do? Okay, right? I could say that print if this number is greater than 20, this number is less than 20. Now, while I am doing this, I want you to know that these two blocks of code cannot run at the same time. Yes, these two blocks of code cannot run at the same time. It has to choose one. Is either a truth or a false? Like, is either true or false? That's it. All right, this number is greater than 20 or 20 itself. So this is how to write if-else statements. Now, the key thing to take away from this class is that if statements, like if-else statements at this point now, they don't run, you cannot run both of them at the same time. If this program runs once, it will either do this one or this one. It can never do both. Okay? I want to ask, do you have any questions about this? Do you understand it?
Yes, I do. It's kind of like the C programming.
Yeah, well, so for the records, programming is the same everywhere. This thing I'm teaching you, like the steps you are using to learn Python, will be very similar steps to, I think I said this in the first class, if you are learning any other language. The only thing may be what we call OOP, object-oriented programming. And then if you are learning a language like Python, you may do a full Python class and nobody will say anything about OOP. But it's very impossible for you to learn Java and nobody mentions OOP. Yes, so if you have never heard of OOP before, just don't worry, you are safe, right? But yes, it's called object-oriented programming, and simple languages like Python don't involve that. So the principle of learning any language, whether it's Python, Go, Java, C#, these conditionals I'm teaching you is, like, I don't mean you write the code the same way, but the principles are largely the same, right? Actually, Python is actually C under the hood, in case you are not aware. Some of these very simple languages are using all those other complex programming languages under, but you will not see it. So I don't know, that's story for another day, but I hope you get the point. The principles of programming are largely the same everywhere. Okay, so it's either you do this one or this one. You cannot do both, right? So now let me also now add something to it. Okay, I can also come here and say, what if I have 3 conditions I'm checking for, right? Now, to show you this, let me remove this equal to for a moment. Okay, let me remove the equal to. I want to say if number is greater than 20, right? Let us do this number is greater than 20. I will also now say that. Wait, did I run this code safe? I didn't run it. Let me run it so that we check that it's working now. Okay, so let me write a number that is not greater than 20. Let's say 12. 12 is not greater than 20. This number is less than 20. All right, you can see that. So now I want to add another condition here. The condition is, so the way we say it, we call it elif. Actually, it means else if. That's what it's just a short form in Python, else if. So now, why would we ever want to do this? We want to do this if we have multiple conditions and then we only want one of the conditions to be true. That's just the idea. Okay. So for instance, let's say I want to do if num is equal to 20. Right. I could say print the number is actually 20. Okay, so I'm going to run it. I'm going to do 20. The number is actually 20. And just so that you don't think that, the computer is is not doing its job well, let me check that. Let me do one very big number. Let's do 24. Okay, all right. So this is what it says. So this is the first one. This number is greater than 20. So this is also something to show, because I made a mistake here. Of course, the computer will not now change what I wrote. It's going to do exactly what I said. This number is greater than 20. And let's test the final one. So let me just read this code for you. Number one, if num is greater than 20, print that this number is greater than 20. If this does not happen, come and check. Is it 20? If it is 20, do this one. If this one and this one is not true, then do you know what? Any other thing that happens, I beg, just print this number is less than 20. Any other thing that happens, just do it. Any other thing, emphasis on any other thing. Now, the reason why I'm saying it is that elif and else are not the same thing. They are very different. Okay? If what you did here doesn't work, what you did, in fact, you can also have multiple elif statements. I think that's something I need to mention. So let's say, for instance, we want to say elif 5 different times. It will still work. Let's say elif num is equal to 24. I can say print the number is 24. Okay, so I can have multiple elif statements in between. Also, I can decide that I don't want an else statement. I can also remove it. Okay, so but the only thing is you can't have an elif without an if, and I don't think you can't have it's not possible to have else where there's no if. So if is like the beginning of the whole thing. Okay, so let's run this program and we will be good to go. Let's do 24. So, but there's a problem with this code. The problem is that if this code is going to work, if I put 24, this code will run, which means that this one will not run because it will not get to this point. Okay, it's 24 greater than 20, obviously. So that's going to happen before before anything runs, and so it will just print this guy, and that will be it. But I need to say something here. There's something called the return keyword, which can make the program stop working, like stop running, stop checking your stuff. But I'm not using the return keyword here, so let's see what happens. I think it should be able to do multiple things. So let's try it, since I ain't using the return keyword. So this number is greater than 20, and then the program ends. So you didn't get to this part, unfortunately. In a later class, I'm going to introduce you to writing functions, and then I'll talk about what the return keyword actually is. Okay, but the major point I want you to take away from this class is that if you have if, elif, and else statements, or even just if and else statements, you can't have the program run all the blocks at the same time. It will only run the first true value. That's what is going to happen. Okay. Also, I want to make mention of the fact that I can actually come here and add a boolean, an exclamation sign, to negate the truth, the value of something. Okay, I don't think this is going to work here. It will probably, after I've done num is equal to 20, I could come here and say not. It's a keyword. So this truth value now is whatever this thing is greater than 20. Okay, in order for me to make it false, I can add a way to say that okay, if not truth value, let's see what is going to happen. It's like it turns the whole thing upside down. If it's true, makes it false. If it's false, makes it true. I also think that you could use this exclamation mark to do it, but because this is a variable, it's not working. It's supposed to be embedded inside here. So let's try the not and see what goes on. Okay, let's do a number that is greater than 20. Let's say 30. All right. So it was true before. Sorry, excuse me. But then it comes back and thank you very much. So it comes back and then it is changed to be like, well, even if this was true, let's change the value. It changed the value, and then what we're now having is that, this number is less than 20. So that's actually one of the ways that you can change the truth value of a statement. You can use the not keyword, okay, to change the truth value of a statement. So I think this is actually a lot of talk for today, and then we have done if else, and then we have done else, okay. So that's actually a lot of talk for today. In the next class, I'm going to introduce you to other ways of doing conditionals, and also let's see, maybe we can write a demo program in the class. So it's 9 o'clock on the dot, and I could say that you have come to the end of today's class. But do you have any questions? Questions from anybody?
No, sir. Maybe tomorrow class I will definitely have some questions. I've had my hands around this else if and all. So you know that there are some times where you now have multiples, and it gets complicated. You know that, like you said, the indentation. That is how the else, when you have an else if, and then you have an else for a particular else if, right? So that else now has to be indented to that particular else if.
Yes.
I'm sure that works, right? I don't know how to explain it, but I know something like
Yeah,
that.
you are
has
right.
happened.
You are right. I think there's what we call nested if statement. So inside this if statement now, I can come under it and still write another if statement again, right? That's also something.
Yes.
Yeah. So we'll look at it in next class. That's a very good question. We'll look at it in the next class. Okay. So
Thank you, sir.
You're very much welcome. With that, we have come to the end of today's class. See you tomorrow.